Okay, I want you to peek at this one for a minute. What do you notice? You see anything? Yeah, let's peek at it. This right here, we can rewrite that, okay? So I don't want it to trip you up. I just need you to know that you can rewrite that to a different format. And what we're going to do is we're going to rewrite it as negative x plus 5. Now that's not the same as x minus 5. The x is negative and the 5 is positive, so make sure you write it the correct way when you rewrite it. And then just bring the other ones down. And that's going to help us to figure out what we have without tripping us up. So this one right here, beware for those because they're in there. They're like snipers. They'll come out and get you. Now, let's see what this says. What are we working with here? So I've got an x times a negative x times an x times an x. Well, right there, there's x to the fourth. So we've got a fourth degree polynomial, which we call a quartic. Is our a positive or negative? Well, I've got a 1 times a negative 1 times a 1 times a 1. Oh, that's a negative 1. So that means that we're going to have a negative quartic. When you have a negative quartic, what does that look like? Well, a quartic is a fourth degree, which means you're going to have n behavior that's the same. There we go. So it's either start up, end up, or start down, end down. And because a is negative, we are going to anticipate a start down, end down with a squiggle in the middle. So it'll look kind of like an M. This is what our rough sketch looks like. Okay, so we should get something like this. It's got to start down, end down. That's our end behavior for a quartic with a negative a value. If you have questions about that, you can go back and take a look at the slides because we went over that previously. Now what we're going to do is we are going to find our y-intercept. Our y-intercept, when it's factored, is multiplying your n numbers together. So I've got negative 2 times positive 5. That's negative 10. Negative 10 times 3 is negative 30. And negative 30 times negative 4 is positive 120. And some of them really do get up there. So keep in mind that that's definitely a possibility. So what we're going to do now is zeros. You know what's nice about these zeros is it's already factored for us. Don't get tripped up on that guy, okay? We're going to talk about him right now. So we get x minus 2 equals 0. We've got negative x plus 5 equals 0. X plus 3 equals 0. And down here, I'll do x minus 4 equals 0. When you solve this one, you're going to add 2 to both sides. X is positive 2. For this one, you have two options. You can subtract your 5 and divide by negative 1, or you can simply take this negative x and add it to the other side. And when you do, you get 5 equals x, because 0 plus x is x. So that's a quick and easy fix. This one, subtract 3. And this one, add 4. So it's a quartic. We have at most 4 crosses on the x-axis. So we're going to cross at 2, at 5, at negative 3, and at 4. Our shape is going to look like an M. We're going to start down, end down, and we got to cross the y-axis somewhere at about 120. Let's get this thing sketched. Remember, it doesn't have to be to scale. Just make sure your x-axis and y-axis are labeled. and that you put your numbers in numerical order. So leftmost point on the x-axis, -3. Put a dot. Then I have 2, 4, and 5. And then of course, 0, 120. 120 is positive, so we'll put it up here. Again, not drawn to scale. Remember that it's got to start down on the left bottom, and it's got to end down on the right bottom. And all we're doing is connecting dots. So start down here, connect to your -3. The next dot is 120. The next dot is 2. Pass through. The next dot is 4. Pass through. The next dot is 5. Pass through, and there it is. It's a warped M, but it's an M nonetheless. Just one big hump and one little hump. But that's a perfect sketch, and that's what we're looking for.